As I record this, it is Leap Day, February 29th, 2024. And I find that very appropriate because at this point in your class, the reading material takes a really funny leap. We are assigned to read Chapter 1 and Section 2-3 in Week 1. I'm not sure exactly why it was arranged this way, but some of the material from Section 2-3 is, in fact, tested in Week 1. Some of it is not tested until Week 2, and some of it is involved in your Week 2 discussion. So it's kind of all over the place. And when we get to Week 2, we're going to have to come back to this section and read more of it. So, I didn't design the class, so don't shoot the messenger. It's a little complicated. By the way, if you're in my class, some of this material is repeated, actually. And I will revise your quizzes to avoid the repetition. If you're another student taking this with a different instructor, you're probably going to see some material tested in Week 1 that I don't cover today, because I will be replacing those questions on my own in my own class. Okay, that being said, let's talk about what we need to know from this section. This section actually has the title is actually graphs that enlighten and graphs that deceive. For today's purposes anyway, I'm just going to go ahead and call it special graphs. And again, I'll make a quick note. This material is really not foundational for the rest of this course. We're just going to need to hold on to this knowledge for the first week or two. Okay, so we're going to discuss two special graphs for quantitative data. These are the dot plot and the stem and leaf plot. And these will not be tested in Week 1, but they are part of the Week 2 discussion. So I wanted to go ahead and throw this material out there in case you might like to do your Week 2 discussion early, before the reading assignment. And then there are two other graphs for qualitative data, the pie chart, and I think this is pronounced Pareto chart. Let's go ahead and start with the quantitative data. I actually have StatCrunch open here. StatCrunch is the software provided by Pearson on this platform. And for purposes of my class, this is the only software I use because I like to be consistent and use the same software with everybody. So I can just give one uniform lesson. So I know that there are pros and cons of using Excel and TI calculators. The thing I like about StatCrunch is that it's got these pull-down menus. So I think that makes it a bit more user-friendly than Excel. And then, of course, it's available here for everybody. If you go to statcrunch.com/app, you can access this for free. Just log in with your student username. Whereas if I used a calculator or maybe even Excel, it's not something that everybody would have. Okay, blah blah blah. Let's get busy. So before I opened up this video, I entered in some data here. In StatCrunch, data is generally entered in columns. So variable 1 consists of, I believe, 100 numbers from 1 to 100, or from 1 to 10. And variable 2 is a different set of numbers, and I believe this is 50 numbers from 1 to 100. Okay. So I am first going to demonstrate the dot plot. And I'll go ahead and do this for variable 1 first. So if we go to graph and dot plot, variable 1, compute. So what's happening here is we are taking all of the numbers in the variable 1 column, and we're representing each one as a dot, and we're placing it appropriately on the number line. So the first number in this list is a 6, and so we put a dot here on this 6. Now, if you look further down the list, you're eventually going to come to other 6s. There's another one. And that second 6 will be stacked on top of the first 6. And there is a third 6. So you see the 6s just stack on top of each other. And this shows you that there are 1, 2, 3, 4, 5, 6, 7. I can't count really those dots, but there's about 8 of them. And likewise with all the other numbers in the list. So there are this many 1s, this many 2s, 3s, 4s, 5s, 6s, 7s, 8s, 9s, and 10s. It's just basically what it's doing is it's taking this list of numbers, is putting them in order, and then it is counting the repetitions for each number. Pretty simple. If we do the same thing for variable 2, I chose these numbers to be much more spread out and sparse. So the data might not look quite as appealing to us, especially if we were to do this on paper. I don't know why we would, but it would be really difficult if I tried to do this on the whiteboard, for example. I would have to be plotting I would have to keep track of all the numbers from 1 to 100. It would be really hard to do that. And then since they're sparse, they all kind of stack low. It doesn't really look quite as interesting. So we have an alternative, and that's called the stem and leaf plot. Stem and leaf for variable 2. This is a bit of a weird one, but I put these numbers in order so we can understand this a little bit better. What's happening here is as the decimal point is 1 digit to the right of the colon, and the leaf unit is 1. Okay, what they're trying to tell us here is that we're sort of grouping these numbers. The variable 2 ranges from 1 to 100. So some of these numbers are in the zeros, some are in the teens, 20s, 30s, 40s, and so on. And that's what each row of this table represents. So this means these are the numbers in the zeros, these are the numbers in the 10s, the 20s, the 30s, the 90s. So the numbers in this left column before the colon are called the stems, and they are basically grouping this data into tens. Now, what exactly are the numbers in the zeros? Well, there's a 1 and a 5. And so we just put those side by side in order by the zeros stem. So the 1 and the 5 are called leaves. What number are in the teens? There's 3 of them, and they end in 4, 4, 5. Right? We're only looking at the ones digit here. Oh, well, there they are, 4, 4, 5. What numbers are in the 20s? They end in a 6 and a 7. So there's a 6 and a 7 in the 20s place. So yeah, it's a weird way of sorting data, but the advantage over the dot plot, again, is that they're not so spread out. Now, instead of counting from 1 to 100 by ones, we're kind of counting from 1 to 100 by tens, and then we're just stacking up all the numbers that are in each tens group. Okay, now let's go ahead and move on to qualitative data, the pie chart and the Pareto chart. Pareto chart basically is a special kind of bar chart. Bar graphs and pie charts are the best for qualitative data. All right, so I'm starting over with a clean slate here. In variable 1, I have now asked 14 people what kind of fruit they would prefer with their lunch. Would you like an apple, a banana, or some cherries? So here are their responses. This is qualitative data, so they don't need to be numbers. These, remember, qualitative means that they're usually going to be names or categories. So we would kind of like to figure out how the apple group compares to the banana group and the cherry group. So we can go to the graph and click on pie chart. Let's click it with data. That means that it's going to keep track of all of these numbers and not just any summaries of them. Click variable 1 and compute. And there we get this nice, beautiful pie chart. Now we have apple, banana, cherry, pie. I'm getting hungry. Okay, so basically we can see that the apple group is the biggest one. And the banana next and the cherry next. So on a pie chart, each group is proportional to its central angle or to its area. It's pretty intuitive. Now we can also graph that. StatCrunch calls this a bar plot with data, variable 1, And in this case, the heights of the bars are proportional to the sizes of the groups. So we can see that there are 6 apple, 5 banana, and 3 cherry. So in this case, they're actually, we actually know their frequencies as opposed to just their percentages. By the way, this chart will generally put the tallest group on the left and then decrease from there. Your homework has a funny question in it where it asks you which one is better, a pie chart or a Pareto chart. And apparently the answer they're looking for is Pareto chart. I'm not 100% sure why. They're just kind of partial towards Pareto charts. It might be because the Pareto chart preserves the actual frequencies. So when we look at this chart, we can actually see that there are 6 people who said apple, whereas when we look at the pie chart, we only knew that 43% of the people said, oh, it also says 6 there. Okay. So to be honest, I don't know exactly why the textbook authors are biased towards Pareto charts, but they are. So if you see a homework question of that nature, if it asks you about a pie chart and a Pareto chart and it says which one is better, just say Pareto chart and you'll get it right. Know your audience, right? Okay, again, there is quite a bit more in section 2.3, but the rest of it is not going to be necessary until we get to homework 2. So I'll save the rest of that for next week's lecture.